Hello, beautiful, wonderful young minds. You are in this class. All being well, this video will bring you meaningful learning experience and expand your senses. And if this brings you good vibes, do hit the like button and share with your like-minded friends. Also, don't forget to hit the notification bell for new video lessons in the future. So let us consider the following. A slipper hit the empty tin can in a tumbalada game, which caused it to move. An object lifted to a certain height using a rope elevated the object from the ground. Or a swimmer moving forward and pushes water back with her hands, reducing drag force. The engine was started and the motorboat moved forward. In all these situations, forces acting on the objects are doing work. An object requires energy to do work. Consider two objects A ball, and object B, a plastic bottle, that are about to interact with each other. When object A is pushed, an applied force is doing work on it. Object A possesses kinetic energy while moving towards a stationary object B, in this case an unmoving plastic bottle. In this situation, the ball loses energy while the plastic bottle gains energy. When this happens, energy is transferred from object A to object B. This indicates that any object that has energy can do work. Do you know that slingshot, or elastico like the bow and arrow in archery, when rubber is pulled in slingshot, there is a potential energy, and when the rubber is released, it is converted to kinetic energy and movement of the sling stone. The rubber pushes out the sling stone from its small pouch and its driving force behind the motion. The harder the pull on the rubber, the greater the potential energy, and thus the greater the kinetic energy of the sling stone. This demonstrates third law of motion quite well, as it converts the potential energy of one ball into kinetic energy that is transferred down the line of balls and ultimately results in the upward swinging of the last ball. Let's get familiar with the following terms that will help you get the most of the lessons. As you already know, energy is the ability or capacity to do work. Its unit is the same as the units of work, expressed in joule. In the international system of units commonly known as the metric system, 1 joule is the energy needed to accomplish 1 joule of work. A larger unit of energy called kilojoule is sometimes used. 1 kilojoule is equal to 1000 joule. Force is a push or a pull on the object. Its units is in Newton. Another is gravity, which is a force that attracts a body towards the center of the earth or towards any physical body having mass. Its constant value on earth is 9.8 meter per second squared. Speed or velocity is a scalar or vector quantity pertaining to how fast an object is moving. Mass is the amount of an object or the amount of inertia of an object. Its unit is in grams or kilogram. Height is the measurement from the base to top or any elevation above the ground or a recognized level, typically sea level. Its unit is in meter. Directly proportional means that as one amount increases, another amount increases at the same time. In real life example, earnings is directly proportional to number of hours worked. For instance, you are paid 25 pesos an hour in typing job. How much you earn is directly proportional to how many hours you work. Working more hours get more pay and direct proportion. So if you work 2 hours, you get 50 pesos. And if you work 3 hours, you get paid 150 pesos and so on. Inversely proportional indicates that as one amount increases, another amount decreases at the same rate. Its symbol is inversely proportional to 1 over b. Talking about speed and travel time, as speed goes up, travel time goes down. And as speed goes down, travel time goes up. Also, energy exists in different forms. In this lesson, we will focus more on the two most common kinds of energy. The potential and kinetic energy, where you will be able to identify and explain the factors that affect potential and kinetic energy. Potential energy is stored energy that depends upon the relative position of various parts of a system. Firsthand, we will determine the characteristics of these energies with respect to potential energy with regards to mass and position. The two objects are placed 5 meters above the ground. The mass of the first object is 10 kilograms, while the second object's mass is 20 kilograms. In this case, when two objects having the same distance from the ground, the object with greater mass has more potential energy than of the one with the lesser mass. In the second figure, the two objects have the same mass. The first object is 5 meters away from the ground and the second object is 3 meters away from the ground. Comparing the two objects, the object with greater distance from the ground has more potential energy as compared with the other object. Following steps in dealing with worded problems, the general equation for potential energy is mass times acceleration due to gravity times height, where the symbol EP stands for potential energy with a unit of Newton meter or joule, in symbol Nm or J. M stands for mass in kilogram. G is for acceleration due to gravity in meter per second squared. Remember that force of gravity is the force exerted by the earth on all things. It is always directed downward or towards the center of the earth. Consequently, when an object is raised from the earth, the force exerted in lifting the object is equal to its weight. Acceleration due to gravity is 9.8 meter per second squared, which is constant. Moving on, h is for height measured in meter. In physics, The kinetic energy of an object is the energy that it possesses due to its motion. It is defined as the work needed to accelerate a body of a given mass from rest to its started velocity. Having gained this energy during its acceleration, the body maintains this kinetic energy unless its speed changes. Let's determine the characteristics of these energies with respect to mass and speed. The two objects have the same speed, which is 20 meters per second. The mass of the first object is 15 kilograms, while the second object mass is 30 kilograms. In this case, when two objects have the same speed, the object with greater mass has more kinetic energy than of the one with the lesser mass. The two objects have the same mass. The first object travels 10 meters per second, while the second object travels with 20 meters per second of speed. Comparing the two objects, the object with greater speed has greater kinetic energy as compared with the other object. Following steps in dealing with worded problems, the general equation for kinetic energy, where the symbol EK stands for kinetic energy with a unit of Newton meter or joule. M stands for mass in kilogram, and V for speed or velocity in meter per second.